This video looks at using the SOHCAHTOA equations to find missing sides when we know one angle and one side. Now the first step is always to identify which sides are involved, which one is the unknown and which one is the known. Now in the first one, the 13 is the hypotenuse, it's opposite the right angle. But the unknown is opposite the angle, so that's called the opposite. And we then identify which of the equations uses opposite and hypotenuse. Well, it's the sine equation. So, sine, now the x here in the equation is the angle, not the x in the question. So, sine of the angle, in this case 42, is equal to opposite, which is x, over the hypotenuse, which is 13. So to find x, I need to rearrange this equation by timesing by 13. So x equals 13 lots of sine 42. So I input that into my calculator as I see it, 13 times sine of 42, and I get 8.7. So x has a length of 8.7. Okay, the second one. We have a known and an unknown. Now the unknown y is opposite the angle, so that's the opposite. Whereas the 10, it's not the hypotenuse, it is next to the angle, it is the adjacent. So again, adjacent opposite is tan. So tan of the angle 37 equals opposite y over the adjacent. So again, to find y, I must rearrange the equation by timesing by 10. So y is 10 lots of tan 37. So I input that into my calculator, 10 lots of tan of 37, and the answer is 7.5. So y has a length of 7.5. Now then, the third one, angle, known, unknown. The unknown is opposite the right angle, that is the hypotenuse. This side here is next to the angle, it is the adjacent. So adjacent hypotenuse is cos. So cos of the angle, which is 41 in this case, is the adjacent 13 over q, which is the hypotenuse. Now then, this is a bit different to the first two equations, because the unknown is now below the equation. So to rearrange this requires two steps. I first of all times up by q. So q, lots of cos 41, is equal to 13. I've times by q, like I times by 10 and 13 here. So to find q, I now divide by cos of 41. So q is 13 divided by cos of 41. So I input that into my calculator. So 13 divided by cos of 41, and I get 17.2. So q has a length of 17.2. The skills are to identify the two sides in the question, to write down the equation, and then to solve it either using the one-step method when we want the known on top of the equation, or the two-step method when the unknown is beneath the equation. That is SOHCAHTOA, finding sides. This video talks through how to find missing angles when you know two sides. Now then, the first step is to label the sides either opposite, adjacent or hypotenuse. Now the hypotenuse is always the longest side opposite the right angle. So hypotenuse, hypotenuse, hypotenuse. From the first triangle, that's not given, but we give them the side opposite the angle. So that's the opposite, and we know the other side, which is next to the angle, that's called the adjacent. Right then, we then identify which of the SOHCAHTOA equations to use. Now we know the opposite and the adjacent, So we use the tan equation. So tan of x is equal to opposite over adjacent. Opposite over adjacent, or 5/12. Then to find out x, we have to do the inverse tangent function, or shift tan on the calculator, or inverse tan. So it's inverse tan of 5/12. So we put that into our calculator and we get the answer, which is 22.6 degrees. The second question, we know two different sides. Here's our angle. One of them is the hypotenuse because it's opposite the right angle. This one here is not opposite the angle, it's therefore the adjacent. So we know the adjacent and the hypotenuse. So we identify which of the equations uses those two sides. It's the cos ratio. So cos of x is equal to adjacent over hypotenuse. Adjacent over hypotenuse. So 4/13. So to find x, we do the inverse cos of 4/13. So we put that into our calculator. Inverse cos of 4 divided by 13, and we get 72.1 degrees. So the final one, here's our angle. Now that one there is the hypotenuse, and this side is opposite the angle. So that's the opposite. So opposite hypotenuse, it's the sine equation. So sine of x equals opposite over hypotenuse. So to find x, we do the inverse sine of 5/10, or a half. So we get x equals 30 degrees. So there we go. That is how to use sine, cos and tan to find missing angles. In this question we're asked to find angle x to one decimal place. Now we're given two sides. Now this side here is next to, so is adjacent to the angle. This side here is opposite this given right angle. So that one is the hypotenuse. Now to solve this, we'll either involve sine, cos or tan. Now so, car, toa gives us a way of remembering whether it's sine, cos or tan. Now I've got the adjacent and the hypotenuse, and A and H occur here. And this equation tells us that cos of the angle, which is x, is equal to the adjacent, which is 6.4, all over the hypotenuse, which is 9.6. Now then, I want to find out what x is. So to find x, I must use the inverse cos button, which can be found by pressing Shift cos. And it comes up as cos minus 1. So x equals cos to the power of minus 1 of 6.4 over 9.6. That's the inverse cos function. So if I put in 6.4 divided by 9.6 and press enter, it gives me 48.2 degrees to one decimal place. In this question we're asked to find a missing length, x, and we know one side and an angle, and this should indicate to us that it's a question involving sine, cos and tan. And we know so car toa, which gives us three equations linking the sides and the angle. Now we want to find the opposite, and we know the hypotenuse. So O and H are the sides which are involved, which tells us that it's sine. The S is for sine. And this says that sine of the angle, which is 60, is equal to opposite, which is x, over the hypotenuse,
which is 32. So to find x, I've got to work out sine 60 times by 32. So I get my calculator and I work out 32 times sine 60, checking that my calculator is in degree mode. There should be a D there. I press enter, get a surd, press the S to D, and get the answer. Now we want it to free SF, so I want to round the third figure, so 27.7. After the 7 is a 1, so therefore it stays at 27.7. So x is 27.7 to three significant figures.
This question asks us to find the length CD to three significant figures. I'll call this length x. Now to find this length here, I must first of all find that length there, because I must know another length in that triangle. So let's consider that triangle. I will sketch it out here. Now we know that 16 is the hypotenuse. This is 12. So let's call that y. Now because there is a right angle there, we can use Pythagoras. So y squared plus 12 squared equals 16 squared. So to find out y squared, I work out 12 squared, which is 144, and 16 squared is 256. So y squared equals 256, take 144, which is 112. So y equals the square root of 112. Now I will leave y as a surd. So I now know that this length here is root of 112. So if I now sketch out this triangle here, let's see what we've got. So, angle of 40, x is unknown, that's root of 112. Now then, here's an angle, here's a right angle. X is the hypotenuse, and root 112 is the opposite. Now if I consider so, car, toa, then opposite and hypotenuse come with sine. So if I come back over here now, I know that sine of my angle of 40 must equal the opposite, which is root of 112, all over x. So to find x, I times by x and then divide by sine 40. So x equals root of 112 divided by sine of 40. So if I get my calculator, I put in root of 112 and divide by sine of 40, which gives me 16.5 centimetres to 3 SF. Now the key thing here is it asked for the length to three significant figures. So keeping my opposite as root of 112 rather than decimal meant my answer became more accurate. This video looks at the two basic examples of using the cosine rule. One to find a side and the other to find an angle. Now I personally call cosine rule the SAS rule. It's where we have a side, an angle and a side in this sort of configuration, and we want to find the opposite side to the angle. And the rule generally is given like so, but we must adapt this rule to our given numbers and letters. Now A is always the side opposite the angle, so m squared, and B and C are the other two sides. It does not matter which way around you have B and C. So we'll have 5 squared plus 7 squared, and then take away, again B and C, two lots of 5 and 7. And A is the angle enclosed between the two known sides, so cos of 32. And to work out m squared, you just input that formula into your calculator. Press enter, and we get 14.64 to 4 SF. Then to find what m is, we just have to work out the square root of that particular answer. And we get 3.83 to 3 SF. So again, to find a side opposite an angle when it's contained within two known sides, we use the cosine rule. Now we can also use the cosine rule to find an angle given three sides. And again, the trick here is to identify in this rule which side is which. Now A is always the side opposite the angle in question, albeit in this case a y. So that's A, and then B and C are just the other two sides in any order, and A is the angle in question, so y is the angle. So for the formula a squared equals b squared plus c squared minus 2bc cos of the angle, we have 4 squared equals 5 squared plus 7 squared minus 2 times 5 times 7 times cos of, in this case, y. And the trick here is to be able to rearrange this formula, and it's not too tough to do. So we work out the squared parts first and get 16 equals 25 plus 49 minus 2 times 5 times 7 is 70 cos of y. Then 16, add those together, we get 74. Take away 70 cos of y. And we want to get y equals, but step one is to work out what cos y equals. So if I take away 74 from both sides, I end up with minus 58 is equal to minus 70 cos of y. I then divide by minus 70. So I get minus 58 over minus 70 equals cos of y. And that is my equation for cos y. In this case, the minus signs actually cancel out. So basically, to find y, I must do the inverse cos of that fraction. So y equals the inverse cos. Again, the two signs cancel out. So 58 over 70. Press enter, and we get 34.0 degrees to 3 SF. So the cosine rule can be used to find a missing side or a missing angle. In another video we apply this to bearings and problems in real life, and also consider a rearranged form of this to speed up this particular calculation here. This video talks through using the sine rule and shows two basic examples. Now the sine rule is used where we have angles and sides which are opposite each other. And in the first triangle, these here pair off. The x and the 37 degrees, the 5 and the 42 degrees. Right, so to find x, we write down x and we write it over sine of the opposite angle. And what the sine rule tells us is that x over sine 37 will equal the other side over sine of its opposite angle. So this gives us an equation to use to find x. So if we now multiply through by sine 37, then x will equal 5 over sine 42 times by sine of 37. And if you enter this into your calculator, you get x is 4.50 to 3 significant figures. So the sine rule can be used to find out a missing side, as long as we have pairs of sides and angles that are opposite. We can also find missing angles. So in the second example, we still have the angles and sides pairing off. But we want to find an angle. Now we can actually spin the ratio over. So if I begin with x, then with the sine rule it says that sine of x over its opposite side, i.e. 7, must equal sine of the other angle over its opposite side, i.e. x. Now to solve this equation requires 2 steps. We first of all must times up by the 7. So this tells us that sine of x is sine 42 over 8 times by 7, which works out at 0.585 to 3 decimal places. Then, to find x, we then must do the inverse sign. This is the second F or shift sign button on the calculator, but inverse sign of this decimal. And if you press enter, you get 35.8 degrees. We're told x is an acute angle, so therefore that is the solution. In the second video, we look at other cases, including finding obtuse angles. But there we go. The 2 examples, finding a missing side or finding a missing angle. This question looks at a cosine rule question in a context of bearings, and we're told 2 things. So Jack walks from town A for 10 miles on a bearing of 20 degrees, and Peter walks from town A for 13 miles on a bearing of 130 degrees. So we're going to do a sketch of this to be able to see what's going on. So Jack walks from town A, and a bearing is an angle clockwise from north. So as a sketch, he walks an angle of 20 degrees and he walks for 10 miles. So that's where Jack ends up. Now Peter walks further on a larger bearing. So the full angle, it's 90, a bit more, is 130. That's the entire angle round. 13 miles. So here is Peter over there somewhere. And the question is how far is Jack from Peter? So we want that distance there. Now if I redraw this as a triangle, so A to J, A to P, and then again on your sketch, my question is what is this value here? That's 10 miles, that's 13. Now this angle here is the difference between these 2 angles. That was 20, that was 130, so that's 110 degrees. And what we observe is we've got the typical SAS, side angle side, configuration required for the cosine rule. Now the cosine rule is a squared equals b squared plus c squared minus 2bc cos of a. Now we want to find out what x is, and that's opposite the angle. So x replaces the a in this formula. Now b and c are the other 2 sides. Take away 2 times 10 times 13 times cos of the angle. So there we go. So x squared will equal this worked out on the calculator. So 357.9. So x will be the square root of this. So square root of this answer, and we get 18.9 to 3SF. So Jack and Peter are 18.9 miles away. This video looks at a fairly routine example of the cosine rule and also how to find the area of a triangle. Now in part 1 we're asked to find AD. So this is the length within this triangle here. So let's call that x. Now because we know the two sides and the opposite angle, we can use the cosine rule, which tells us that x squared must equal 9.8 squared plus 6.4 squared minus 2 lots of 9.8 times 6.4 times cos of the angle 53.4. So this formula here gives us a value for the side we want squared. This gives us that x squared is equal to 62.2. So to find x, we just do the square root of 62.2, which works out at 7.9 centimetres to 1 decimal place. So again, if we know two sides and a angle between them, SAS, we can find the side opposite the angle using the cosine rule. Now part 2 asks for the area of triangle ABC. Now then, if we know two sides and a contained angle SAS, then we can find the area using the formula half AB sine C. That is a general formula for the area of a triangle. Now we know two sides, but we don't know the angle here, but we can find that quite easily, because that there is a straight line. So to find the missing angle, I do 180 take the known angle. So 180 take 53.4 is 126.6. Those two add to 180. I now just use a half. A and B are just those two sides in any order, so I'll do 9.8 times 7.3, and then times by sine of the angle, which is 126.6. Put that into the calculator and we get the answer 28.7 centimetres squared to 1 dp. Just one comment to make on an A-level paper: these are given in degrees, so make sure that you use your calculator in degree mode. On some exam papers they can also be radians, and the distinction is quite important. This question asks us to find the area of this triangle, giving our answer to 3 significant figures. Now generally, if we know a triangle, and if we know an angle, and the two sides which form the angle, then the area will equal a half A times B times sine of the angle. So I need to know somehow two sides and an enclosed angle, and I just know one side at the moment. However, if I call this side here x, then I can use the sine rule to find that missing side, because I know pairs of opposite sides and angles. Now the sine rule says that x over sine 49 is equal to 8.7 over sine of 64. So x will equal 8.7 over sine 64 times by sine of 49. So 8.7 divided by sine of 64 times by sine of 49 gives me the side 7.305. Now then, I therefore know x so if I know the angle contained within, then I'll know two sides and an angle. But I can find that angle. If I do 180, take 49, take 64, then I can find the angle here to be 67. So the area will equal a half times 8.7 times by this side here times by sine of 67. So if I get my calculator, 0.5 times 8.7 times 7.3053 times sine of 67, then my answer is 29.2518. I wanted to free SF, so the area is 29.3 centimetres squared to free significant figures. This question asks us to find the relationship between the area of a triangle and x. Now we know that if we know two sides and an angle, then the area, which we'll call A, is a half this side, which is x, times this side, which is 2x, times sine of the angle. Now, the half and the 2 cancel out. So A equals x squared, but if you work out sine of 30, that equals a half. So A equals x squared times a half, or x squared over 2, because sine 30 equals a half. So to find x in terms of A, if I times by 2, then 2a equals x squared, which means that if I square root both sides, then x will equal the square root of 2a. I've therefore shown the result as required. In this question we're given the net of a square-based pyramid which is not drawn accurately, and we're asked to find the area of one of the triangles. Now, because we're told the area of the square is 36 centimetres squared, then this length here must be 6, because of course 6 times 6 is 36. So if I then draw this triangle out over here, then we know the base is 6 centimetres and this angle here is 70. And to find the area of a triangle, if we know an angle and two sides, then the area is a half this side here, which is 6, this side here, which is x, times sine of the angle. So if we know two sides and an angle, this is the way we can find the area. But we're missing the side here. But I can find x in the following way. If I cut this shape in half, then I've got a right-angled triangle with an angle of 70, and this length here must be a half of 6, which is 3 centimetres, and this is x. So I've got an angle, an adjacent, and hypotenuse. So A and H tells us that cos of the angle must equal adjacent over hypotenuse. So I can solve this to find x. If I cross multiply, I get x cos 70 equals 3. So x equals 3 over cos of 70. So if I get my calculator and do 3 divided by cos of 70, I work out that x is 8.77 centimetres to free
significant figures. So back to the area, knowing that x is 8.77, the area must equal a half, 6 times 8.77 times sine of 70. I've got the 8.77 stored on my calculator accurately, so if I times this by 6, divide by 2, and times by sine of 70, press enter, the area is 24.7 centimetres squared. This video looks at how to find the area of a triangle given three sides. Now, if we know two sides and an angle, let's call the angle x, then the area is given by a half BC sine of x, where B and C are the two sides which form the angle. B and C or B and C, it doesn't matter which way around you do that. However, we're missing the angle, so we must somehow find out this angle to then use the area formula. Now, to find the angle, we can use the cosine rule. And the cosine rule says that cos of x is equal to, and the formula is b squared plus c squared, take away this side here which is opposite, we'll call a, take away a squared, all over 2 times b times c. So I can find x in the following way. So cos of x equals, so b squared plus c squared, take away a squared, all over 2 times b times c. So if I put this into my calculator, I've got 75 squared plus 92 squared, take away 105 squared, all divided by 2 times 75 times 92. So if I press enter, that gives me cos of x equals. So to find x, I will do the inverse cos of this. So if I press shift cos and just press ans, it will use the memoried value of 0.222. Press enter and I get x is equal to 77.2 degrees to 3SF. So again, I've inverse cos of the value above to get 77.2 degrees. So I now know x, so to find the area, I will just do a half times b times c times sine of the angle. So I have the angle stored here accurately, so 0.5 times 75 times 92 times sine of the previous angle, press enter, and I get 3363.9. So 3363.9 meters squared to 5SF.